Hello, I'm Roman, a hardware engineer at Droid Technologies. I specialize in designing both digital and analog devices. My responsibilities include schematic and PCB design, signal verification, prototype testing, and preparing the hardware for certification and mass production. In this video, I will guide you through understanding how to design a PCB that includes high-speed lines. We will open topics: rounding lines, impedance matching, clocking, EMI and TMC in high-speed lines. For better understanding, we will open one of the projects that was designed by our team and demonstrate it more visually. When we talk about rounding lines in PCB design, we are referring to replacing sharp 19 degrees corners with smooth, curved paths. Instead of abrupt angles, the lines follow gentle arcs, creating a more fluid and continuous connection between points. To get a better idea, let's take a look at the project and see how these lines look. Rounded corners help improve signal integrity by reducing reflections and TMI, especially important for high-speed anti-ref circuits. They also reduce mechanical stress during manufacturing, making the board more reliable. At the same time, the lengths of parallel lines must be matched. The signals should arrive without delay difference between each other. Let's use Altium Designer and set up rounding lines. To achieve proper impedance matching in your PCB design, you need to follow a few key steps. First, define the type of transmission line: microstrip, strip line, or coplanar. Then control the geometry: trace width, distance from the reference plane, and copper thickness. All matter. You also need to know your dielectric material and its epsilon R, whether it's FR4, Rogers, or something else. Target the correct impedance, for example, 50 ohms for single-ended traces or 100 ohms for differential pairs. And don't forget to use impedance calculators or controlled impedance tools in your PCB software. Even small changes can lead to signal integrity issues in high-speed design. In high-speed designs like DDR4, EMI/EMC performance is influenced by return current path, signal loop areas, trace impedance control, layers transitions, FIOS, and proper terminations. Stack-up quality, decoupling power integrity, trace length matching, and crosstalk minimization, for example, 3-width rule, are also critical. Good component placement and SI simulations further reduce emissions and improve system stability. Design of the device with high-speed lines requires high-qualified engineers who will be responsible for the design and can bring up the device and run it into production. At Droid Technologies, we're here to assist your embedded design projects, covering electronics, firmware, software, mechanical designs, and ensure successful implementation and optimal results.